Hello guys, welcome to another video. This one is paper 3-2 of October-November 2018. This is paper 3 of A-level math. So just remember that the most important thing right now is to understand on how to do those questions step by step. So with that being said, let's move on to question number 1. So here we have to solve the equation, basically find the values of x. So the first thing you see is that we have modulus on both sides. So whenever you see that, the first reaction we have to have is to square both sides. So we square both sides. Minus 1 square is more than x plus 4 square. So when you square both sides, the modulus will be eliminated. Okay, you will have 9 and you will have 2x minus 1 square more than x plus 4 square. Now we have to simplify by expanding those two brackets. So 9 is 9. This becomes 4x squared minus 4x plus 1 is more than x squared plus 8x plus 16 for this side. Now we have to expand this bracket as well. That will be 9 times 4 is 36x squared minus 36x plus 9 is more than x squared plus 8x plus 16. Now one thing we do is we send everything to one side, right? So 36 minus x, that will be 35. So it is 1, not x, 1. Now minus 36 minus 8, that will be what? Minus 40, 44 x. And plus 9 minus 16, that should be minus 7. That is more than 0. Okay, so we can check just to make sure. So minus 36 minus 8 minus 44, 9 minus 16, that should be minus 7. Okay, so when we have this equation, we have to find the critical values for x. So to find the critical values, we just have to take this equation and equate to the value of 0. Okay, so that is this, and we write equal to 0. Now we have to factorize that and find the values of x. So factorize. Here you will have 35 is 7 times 5. So 7x times 5x. And 7 is 7 times 1. So 7 here and 1. Now to get minus 44, we have to have 7x times minus 7. That will be minus 49 plus 5, that will be minus 44. So the first value will be, so we have to equate that to 0, and then we solve for the value of x. So x will be minus 1 over 7, x will be 7 over 5. But these are only the critical values of x. So basically to find the real solution, we have to look at the equation. So here we observe that this is positive value. So our graph will look something like this. This is the line of 0. Because it is positive, it will look something like this. And these 2 points here will be your critical values. This is minus 1 over 7, and this is 7 over 5. So here we want to be more than 0. It has to be above 0, so it will be this side and this side. And that is only possible when x is less than this, or if x is more than 7 over 5. Okay, so this will be your two set of values for x. That is true. So this will be your solution for question number 1. Also, just to simplify, how do you expand this? So let's say I have 2x minus 1. If you guys don't know, no problem. So what you can do here is you can always take this, multiply by the same thing. You can do that if you want to. Or if you want to, you can simplify directly. You can do 2x squared and then plus 2, this is 2, and then take the first one and take the second one is minus 1, and then plus, we have minus 1 here, square. So you should get the same things, which is this one. So that's how you expand this. This is only a side note for you to understand on how we expand this. But the main point here is, first, when you see modulus, we have to expand both sides by taking square on both sides. Then step by step we simplify, and then we have the equation. So when you reach this equation, we have to find the critical values of x, as you can see, and then to find the solution, we have to use the graph and then find the solution. That will be your question number 1. Now let's move on to question number 2. So here we have to show all your work, solve the equation, this plus this equal to this. Now, so the first thing you see is that these two angles are just theta, but here we have theta minus 30, so it is not the same, so we have to simplify. So from your list of formulas, you will have something like this, which is a minus b, that is equal to sine of a cos b minus cos of a sine b. So this is the formula for that expansion. So we're going to use the same idea here. So here we have sine. In place of a, we have theta minus 34 for b. That will be sine a is theta cos of 30 minus cos of theta sine of 30. So now we have to simplify. So this value here, cos of 30, it is equal to root 3 over 2, and sine of 30 is equal to half. So your answer will be root 3 over 2 sine of theta minus half cos of theta. So this became this. We just have to replace this back in your equation. Okay, so let's replace one by one. So you will have this over 2 sine of theta minus half cos of theta, then plus cos of theta equal to 2 sine of theta. Now we have to regroup. So one thing we can do here is, because we have 2 on the denominator, if you want to eliminate 2, you can just multiply by 2 everywhere. Okay, you will have root 3 sine of theta minus cos of theta plus 2 cos of theta, that will be 4 sine of theta. So now we can simplify. So let's bring everything to one side. Here you will have root 3 sine theta minus 4 sine theta. So this is minus 1 plus 2, that will be plus 1, 0. And for this one, we can just simplify them. So we can factorize the sine outside. You will have root 3 minus 4 plus cos theta. Now, whenever you have a function or expression just with sine and cos, you have to divide by cos everywhere. So you will have tan theta. So this, we can bring this in the front. That will be root 3 minus 4 plus 1 equal to 0. Now if you simplify, tan theta is equal to minus 1 divided by root 3 minus 4. So let's see what is that value. So minus 1 divided by root 3 minus 4. That will be 0.440926. Now this is a positive value, so if tan is positive, it will be in your first quadrant or in your third quadrant. First is just theta. This will be 180 plus theta. So step by step, let's find the value of theta. That will be tan inverse of this one. Let's see what we get. That will be, so we have to use degrees, not radians. Tan inverse of 0.440926. That will be 23.8 degrees. And also we have the answer for 180 plus 23.8. That will be 203.8. But since the range have been given to you, I mean the domain, it is only between 0 and 180, this one will be outside. So the only value that we will take will be 23.8 degrees for the value of theta of this question number 2. Now let's move on to question number 4. So we have to evaluate this integration. So here what do you observe? We have two different kind of expression. Here we have algebra, and here we have a logarithm function. So we have to do integration by parts. So first thing, we have to try to simplify this. So this can be rewritten as x power minus 3 ln of x dx. Now, whenever you have logarithm in the by parts equation, this has to be u, okay, and this will have to be du, because we have to follow the rule of late. So late L always happen first, which is the logarithm. Anything happen first, we have to be assigned to u, so that will be u. Okay, now the formula is usually is uv minus integration of v du. So we know, so u we know already, it is ln of x, and dv it is x power minus 3. So we have to find du, it is 1 over x, and v will be integration of this, which is this, or you can write this one. This will be your v. Now next step is to replace all these values back into this equation. So u is ln of x times v is minus 1 over 2, so this is square, minus integration of v is this one, and here we have du is 1 over x, and we have to integrate with respect to x. So now we have to simplify one by one. So here we can put this one in front. You will have minus ln of x over 2x squared for this one. Now we have this one cancel out, become plus, and we can take out the half outside. You will have integration of 1 over x cubed dx. So we can do this on the side. So what is integration of 1 over x cubed? We can bring the x up, it will become this. Then this is same as this, right? It will become x minus 2 divided by this, which is minus half over x squared. So replace back in your main function. This is minus ln of x over 2x squared plus half times minus 1 over 2x squared. Now simplify. This will be the same thing, and that will be minus 1 over 4x squared. Of course, we have to write plus c for the constant of integration. So this will be your answer for part 1. Now hence, show that this is equal to this. So hence meaning using the value from the first part to integrate and find this value. So we know this is equal to minus ln of x over 2x squared minus 1 over 4x with the limits of 2 and 1. So first we have to replace the values by 2x. So first one will be minus ln of 2 divided by 2 times 2 squared is 8 minus 1 over 4 times, this is 4, that's the first one, and then minus, take the values of x to be 1, minus ln of 1 over 2 minus 1 over 4. So now we have to simplify. Always step by step, so don't rush yourself. So here we have minus ln of 2. We have minus, this is 1, and this is going to be 16. So here we have 8. So let's make it become 16. We have to times 2, so we have to times 2 here as well. Okay, that's the first part. Now minus. So this is 0. So everything will be 0, so that will be minus 1 over 4. Okay, so now we can simplify again. So for the first part, everything is base 16 already. We have minus 2 ln of 2 minus 1. Then we have, so minus minus become plus, plus over, here we have 4, we can make it become 16. We have to times 4 will become 4. Now we can simplify. What happens if you take out the 16? So take out 1 over 16 outside. You will have minus 2 ln of 2 minus 1 plus 4. So that will give you 1 over 16, and that will be 3 minus 2 ln of 2. Okay, so now if you observe, what is this one? What is 2 ln of 2? So 2 ln of 2 is simply ln of 2 power 2, which is ln of 4. Okay, so just replace this back. You will have finally that is 1 over 16 times 3 minus ln of 4, and this is shown as required. Okay, and that will be your question number 3. Now let's move on to question number 4. So showing all the working, solve the equation. So solving means to find the value of x. Okay, so step by step, the first thing we do here is we cross multiply. You will have ex, e power x, plus e power minus x equal to 4 this plus 4. So now we have to simplify. So what is e power minus x? It is 1 over ex. Right, so let's replace. You will have this plus 1 over ex equal to 4ex plus 4. Now, we have to eliminate the denominator. We have to multiply everywhere by exponential of x. So what do you have? So you will have, here you will have exponential of 2x plus 1 equal to 4 exponential of 2x plus 4 exponential of x. So now we can simplify. Let's bring everything to one side. You will have 4 minus 1, that will be 3, plus 4 exponential of x minus 1 equal to 0. So now if you observe, you have a quadratic equation in terms of exponential 2x. But if you don't see it, no problem. So all we can do here is we can let u equal to this. Then you can do 3, that will be u squared plus 4u minus 1. Okay, so now it is easier to understand what's happening. Now we can just factorize the equation to see if it is possible. So 3, that will be 3 times 1, and 1 is 1 times 1. So to get plus 4, we have to do plus 3 and plus 1 to get plus 4. But if you do plus times plus, it is plus, but here we have minus, so this one is not good. So we have to use our formula. The formula will be u is equal to minus b plus minus square root of b squared minus 4 times a times c. And all this divided by 2a, which is 6. Now we have to simplify. U will be minus 4 plus minus, this is 4 squared is 16 minus 4 times 3 times minus 1. That is 28 over 6. But now we know that u is actually exponential of x, and this value is always going to be positive, so we cannot take the minus value. We have to reject that one, so we will remain with the positive value. So minus 4 plus root of 28 over 6. That will be 0.21525. So finally, replace u back by this, because we want to find x, not u, right? So replace it back, and then for the value of x, we just have to send exponential over here. That become ln of 0.21525. And from what I can see, it shows to be minus 1.536. Correct to 3 decimal place. Let's verify this value again just to confirm. So minus 4 plus root of 28 divided by 6. That was the value, and ln of the answer should be that value. Okay, so that will be your question number 4. Now let's move on to question number 5. The equation of a curve y equal to x ln of 8 minus x. We have an equation. Now the gradient of the curve is equal to 1 only at one point, which is this point. Now, whenever you see gradient of a curve, you know it has to mean dy by dx. So just memorize this. Whenever you see gradient, it means dy by dx. Okay. Now we have to show that a satisfies this equation. So step by step, at first we have y, which is your equation, x ln of 8 minus x. But now we know that we are interested with the gradient equal to 1, which is dy by dx equal to 1. So let's first find dy by dx. So now you observe this one is a product. So we have to use our product rule. So dy by dx is equal to, so we can leave this one by itself first and then differentiate this one, you get 1 plus, then we'll leave this one by itself, then differentiate this one, it will be 1 over 8 minus x, then times minus 1. Now simplify, you will have ln of 8 minus x be minus x over 8 minus 1 minus x, sorry. Now from the question we know that the dy by dx is equal to 1, so let's equate that to 1. Okay, now since the base is this, and if you want to eliminate the base, as always we multiply by the denominator, right, which is this value. So you will have 8 minus x of ln 8 minus x is equal to 8 minus x. So x, right. Now we have to simplify. What can we do here? We can try to send, so because here we have to prove that x is equal to this. So let's see how can we make x become your subject of formula. So I will bring this value here. You will have 8 minus x ln of 8 minus x is equal to 8 minus x, and then here we have plus x. So now if I expand this, what happens? Let me see. You will have 8. Oh, so there's no need to expand this, because if I expand this, I actually need this function because we want to make it look exactly like this, right? So what I can do right now is I can try to I should have simplified which part. So let me see what else can we do here, because if I add this, that will cancel out. Okay, yep, so that is correct. So that will become 8 minus x plus x. These two will cancel out. Okay, so you will have, this is 8 over here, and you will have 8 minus x ln of 8 minus x. Okay, that is good. Now you have 8 minus x is equal to 8 divided by ln of 8 minus x. So right now you have this. Now you have to make x become your subject of formula. So we send x over here, we send this over here, you will have x is equal to 8 minus 8 over ln of 8 minus x. Okay, and this is exactly as shown here. So you can write down, this is shown as required. So this is for part 1. Now let's move on to part 2. So verify by calculation that a lies between 2.9 and 3.1. So right now the equation looks like this. X is equal to 8 minus 8 over ln of 8 minus 1. But we know that at dy by dx equal to 1, they mentioned that x was equal to a. Replace, you will have a is equal to 8 minus 8. So this is x. That will be ln of 8 minus a. Okay, so now we have to prove that a lies between those two values. So first value, a is equal to the first value, that is your left hand side. And then let's say a is equal to what? For the right hand side. Replace a in this equation, you will have 8 minus 8 divided by ln of 8 minus 2.9. That will be 3.09. So the left hand side is less than the right hand side. Now we have to try this value. a is equal to 3.1, and this value will be what? This is your left hand side, and this is your right hand side. So now we have 8 minus 8 divided by ln of 8 minus a is 3.1. That will be 2.97. So left hand side is more than the right hand side. So as you can observe, there was a change in sign. At first it was less and became more. You can write down, since there was a change in sign, between the values of a equal to 2.9 and 3.1, it confirms that a lies between 2.9 and 3.1. Okay, that is for part 2. Now let's move on to part 3. So using an iterative formula based on the equation in part 1 to determine the value of a correct to 2 decimal place, but leave the result of each iteration to 4 decimal place. So at first we have the a is equal to 8 minus 8 over ln of 8 minus a. So we have to make it become an iterative formula. So we have to write n plus 1, and this becomes n. So the first value, we have to take the value exactly halfway between those two. That will be 3, right? So let the first value of a is 3. What is the second value? So 3 is your answer for the first one. Then we do 8 minus 8 divided by ln of 8 minus answer. Okay, that will be the second value, 3.0293. A3, 3.0111. A4, 3.0225. A5, 3.0154. What else? Then we have A6, 3.0198. A7, 3.0170. A8, 3.0187. Let's do a few more. 3.0177. And A10, you will have 3.0184. So we only need to give my answers correct to 2 decimal place. So 2 decimal place will be 3.02. And that is your value of a correct to 2 decimal place. And that is your question. So let's move on to question number 6. So a certain curve is such that its gradient is at a point with xy. Okay, is proportional to this value. So whenever you see gradient, you have to know that it is dy by dx. Okay, now when you see proportional, it means the sign and to this value. Okay, so as you can see, we have one equation from the first line of your sentence. So it means that dy by dx is equal to k times y squared over x. Okay, we can change this sign to equal to k is a constant times y squared over x. Now next thing is the curve passes through 2 points, 1, 1 and E2. So these two are passing points. This is x, y, x and y. Now by setting up and solving a differential equation, find the equation of the curve. So what is the equation of the curve? It is basically to find the value of y. Okay, and finally we have to express y in terms of x. So step by step, first we have to set up and solve a differential equation. So as you can see, here we have dx. We have to send this to this side. So you will have something like this. dy is equal to k over x times y square dx. Now here we have y. We have to send y square to this side. This is basically 1. So you will have 1 over y square dy is equal to k dx. So k divided by x and then dx. Now since we have x here and dx, y here and y square, we can integrate both sides. So let's do one by one. So what is the integration of this one? So let's do this on this side. It will be, what is 1 over y square? You can write this as y power minus 2 dy. That will be y minus 1 divided by the power. That will be minus 1 over y. Now what is this one? So same steps. That will become k is only a multiple. So let's write this down. dx. K is only a multiple. We can take out the value of k. And integration of 1 over x is just ln of x. Now we have to replace those values back in the main equation. So let's see what do we have right now. So on this side we have minus 1 over y is equal to k ln of x plus c. This is what we have right now. So make sure you don't forget this value of c, because we need to use those 2 points to find the value of c. So one by one, first let's use this point. This is your x, this is your y. That is minus 1 over 1 is equal to k ln of 1 plus c. So now we have to know that ln of 1 is equal to 0. Okay, so that will become, so here we have minus 1 is 0 plus c. So c will be minus 1. That's the first value that we have found. Now moving on to the next one, we have to find the value of k. So here we have minus 1 over y is equal to k ln of x minus 1. Now to find the value of k, we have to use the other point, which is e, that is exponential, and 2. This is x and y. So replace back in the equation, y is 2, which is 1 over 2, equal to k ln of x is 2 minus 1. So now we have to know ln of e. This is equal to 1. So you will have eventually, this is minus half, equal to k minus 1. So from this, k is equal to 1 minus half, which is half. So that will be your values of k is half and c is equal to minus 1. So your equation right now can be written as minus 1 over y is equal to k is half ln of x minus 1. So now it is not over yet, because we still have to express y in terms of x. So we have to see what can be done. So right now we have basically 1 minus 1 over y is equal to half ln minus 1. Now to eliminate this denominator, we have to multiply by 2 everywhere. You'll have minus 2 over y is equal to ln minus 2. So now we have to cross multiply. This multiply this, this multiply by this. So you have minus 2. So we can bring this one down if you want to. That will be ln x minus 2 is equal to y, because we have to make y become the subject of formula, because we wanted to express y in terms of x. So let's write this down properly now. Y is equal to minus 2 over minus 2 plus ln of x. Now if you want to simplify, you can write down 2. You can divide by minus 1, both up and down. You will have 2 minus ln of x. And that is your answer for y in terms of x for question number 6. So now let's move on to question number 7. A curve have equation y equals to this, right? This is equal to minus half pi, and this is half pi. So if you want to know this in degrees, you have to know that pi is equal to 180 degrees. So that will be minus 90, and this will be 90. So x will be between those two values. Okay. Now question number 1 is to find the exact coordinates of the stationary point. Now, whenever you see this, you have to know that it is asking you for dy by dx equal to 0, because we have to know that at stationary point dy by dx equal to 0. So now we have to find dy by dx. We know y is equal to this. This is a fraction. So dy by dx we have to find by using a quotient rule. So first step is to write down the denominator as it is, okay, and then multiply by differentiation of the numerator, okay, and then minus the numerator, and then multiply by the differentiation of the denominator. Of course, you have to take all this and then divide by the square of the denominator. Okay. Now we can simplify step by step. So on top, what would you have? So dy by dx is equal to, so that is 2 plus sine x will remain the same. Multiply by 3 is only a multiple. Cos will become minus sine. Okay. Here we have minus 3 cos x. D by dx of this will become cos x, and all this divided by 2 plus sine x square. Now as you can see already, we want to equate that to 0 to find the stationary points. So by equating this to 0, we have to cross multiply. So 1 times this will be the same values. So you will have, so here you will have minus 3 sine x times 2 plus sine x minus 3 cos square x is equal to, this will become 0. So now we have this equation we have to solve. Now step by step to see what can happen. So let's expand this first. We have minus 6 sine x minus 3 sine square x minus 3 cos square x. Okay. So now if you observe, what can we do now? We can try to factorize this minus 3 outside. So here we have the same thing for now, minus 6 sine x. Now if you take out the minus 3 outside by factorization, on the inside you will have sine square x plus cos square x, and that is equal to 0. Now from your list of formula, you will see this is equal to 1. Okay, so you will have minus 6 sine x minus 3 equal to 0, and from this you will have 6 minus 6 sine x is equal to 3. So sine x is equal to minus 1 over 2. So as you can see, sine is negative half. So when sine is negative, has to be in your third quadrant or in your fourth quadrant. This is 180 plus theta, and this is 360 minus theta. Okay, so let's see what are the possible values that we can have. So usually we can just do that because as you can see, it is between minus 90 to 90 or minus this to this. We can just try to find it directly. X will be sine inverse of the value. What is that value? That will be minus 30 degrees, which is minus pi by 6. So that is your value of x, which is minus pi by 6, which is this value right here. This angle is minus pi by 6. Minus is only minus here in this case is the direction. So when you say plus, we mean this direction. Minus will be going this direction. So your x is equal to minus pi by 6. So now we have to find the y because we want to find the point, right? So we know that y is given by the equation 3 cos of x, which is this, divided by 2 plus sine of x, which is this value. Now if you simplify, so what is cos of minus 30? It is basically root 3 divided by 2. You can check cos of minus 30 degrees, which is this value, which is root 3 divided by 2. So same value. And for the base, you will have 2. So sine of minus 30 will be minus half. So that will give you 3 root 3 over 2 multiplied by. So let's simplify the base first. So here we have two different base, right? So we have to simplify 2 over 1 minus 1 over 2. That is equal to over 2. That will be 3. Okay. So 3 over 2 will become 2 over 3. Now we'll simplify. This one cancel out. This one cancel out. So you will have root 3 as your value of y. So from this point, we can write down the stationary point. The first value is minus pi by 6. And we have the y value will be root 3. And this is your answer for part 1. Now let's move on to part 2. So here we have to solve this integration to find the value of a. So we have to find the value correct to 3SF. So how would you solve this integration? So by observation, we know that if you differentiate sine, you will have cos. So you will cancel out the cos on top. So we have to use substitution. Okay. So basically, what I mean is the idea here is basically we have to try. We don't know exactly what's going to happen, but we can try things out and see what's going to happen. That's the main concept, right? So that will be a 0, 3 cos x over 2 plus sin x by dx. That is supposed to give you 1. Now I mentioned that I wanted to try let u be equal to sin x. The reason why is because if I do du by dx, I will have cos x. And cos x is equal to cos x here. So they can both cancel out. That's why I wanted to use that value. So make dx become the subject. You will have du over cos x. Okay. Now bring this back in your main equation. You will have integration of a 0, 3 cos x over 2 plus u. Dx will be du over cos x. And that is supposed to give you 1. Now you observe these two will cancel out. So that's why I use that to cancel out these two values. So now what do you have? You will have a simple integration of a 0 and 3 is only a multiple. It will be 2 plus u by du. That is equal to 1. Now we can try to simplify this. So first thing, we can take out the 3 because it is only a multiple, and then that will become ln of 2 plus u. Limits will be a 0, but remember u is actually sin x, so replace this by sin x. So 3 ln of 2 plus sin x between a and o equal to 1. Now solve one by one. So first let's use the value of a. So first we can send the 3 here, right? You will have, let's use a inside, ln of 2 plus sin a, and we use this value, ln of 2 is equal to 1 over 3. Now we can simplify these two when you have minus, right? So you have to know that if you have the same base, let's say we have a minus log of b, that is equal to, because it is the same log, we can say log equal to this over this. So same thing here. You have the same log. It will be 2 plus sin a divided by 2 is equal to 1 over 3. Now to eliminate this ln, we have to send this over here. You will have 2 plus sin a over 2 is exponential 1 over 3. And here we have to make sin a become your subject of formula, so we can cross multiply. So you will have 2 plus sine of a 2 exponential 1 over 3. So from this value, sine of a can equal to 2 exponential 1 over 3 minus 2. So what is that value? 1 over 3 times 2 minus 2. That will be 0.79122. So a will be sine inverse of that value. So here we have to use radians. Here we go. Sine inverse, and that will give you a is equal to 0.913, correct to 3SF. That is the value of a for question number 7. Now let's move on to question number 8. Let f of x equal to this fraction. Part 1 is to let express f of x in partial fraction. So we have to let this equal to a over the first factor, 1 minus 2x, plus b over the second factor, which is 2 minus x, and plus c over 2 minus x squared. Okay. So now we have to find the values of a, b, and c. So we can first multiply this by to the top. So you will have on the left hand side, you will have 7x squared minus 15x plus 8 remaining is equal to, so what is a over this time this? You will have a times 2 minus x squared. What is b over this time this? You will have b times 1 minus 2x times 2 minus x, and plus c times 1 minus 2x. Okay, you will have this equation that you have to solve to find the values of a, b, and c. So the trick we can use here is we can try to eliminate 2 of them to find the one value. So let's say I want to eliminate b and c to find the value of a. So I can look inside here, they have the same factor, right? So I have to say let x equal to half. So how did I choose half? So I take the value inside, which is 1 minus 2x, equate to 0, and find the value of x. So x will be half. So that's why I choose half. So by choosing half, here what value do we have? So 7 half square minus 15 half plus 8. That will be 2 and 1/4 is equal to a. 2 minus 1/2 square is the same value, and b and c will become 0. Okay, so if you test, you put half here, 1 minus 1 is 0, 0 times this will be 0, so this is also 0, so we have only these two values. So here we can just cancel out, so a is equal to 1. That is the first value that we have. So now we have to find the value of b. So to find the value of b, we have to eliminate, so let's first find the value of a, because this one has both factors. It is hard to find at first. Let's first eliminate a and b. Let's find c. So let's take out the value inside, which is 2 minus x equal to 0. So we have to let x become 2. So if x is 2, what is the value on the left hand side? You will have 7 times 4 plus 15 times 2 plus 8. So let me write this down for you guys. So we let x equal to 2, 7 times 2 square minus 15 times 2 plus 8. It is equal to, so here if you put 2 here, that will become 0, and this is also 0, and c will become 1 minus 2 times 2. Okay, so what is this value? We can simplify. 2 square minus 15 times 2 plus 8. That will be 6. And this will become c. So this is 1 minus 4 is minus 3, c. So c is equal to minus 2. So c is this, a is this. Now we have to find the value for b. So to find b, we can just take the simplest value we know. Let's say we can take x is equal to 0. So what is the value on your left hand side? If you take that, you will have, so let's do this here, 7 times 0 plus, so minus 15 times 0 plus 8 is equal to a times 0 will be 2 square plus b, that will become 1, and 2 plus c, that is 1, right? Now we can try to simplify. So this will become 8 on the left hand side, and this will become a, we know it's 1. 1 times 4 is 4, plus b we don't know, which is 2, and c is equal to minus 2. So now we have to solve for the value of b. So 4 minus 2 is 2. 8 minus 2 will be 6. So finally, b is equal to 3. Okay, so we have the values of a, b, and c. So a is equal to 1, b is equal to 3, and c is equal to minus 2. So finally, f of x is equal to a is 1 over 1 minus 2x, plus b is 3 over 2 minus x, minus 2 over this value. So this is your partial fraction for f of x. Always step by step to find the values of a, b, and c for part 1. Now let's move on to part 2. Hence obtain the expansion of f of x in ascending powers of x up to including the term in x squared. Okay, so for this one we have to do step by step. So it is confusing, so let me try to simplify this for you guys. At first we have f of x is equal to 1 over 2, so 1 minus 2x plus 3 over 2 minus x, and then minus 2 over 2 minus x squared. Now we can rewrite this as, if you want to rewrite this, we can do 1 times 1 minus 2x power minus 1 plus 3 2x power minus 1 minus 2 2x power minus 2. So now we have to find the expansion for each term. This term, so not term, but this expression, and this expression. So one by one, this is number 1, 2, and 3. So number 1, so we have to expand 1 minus, so we have 1 minus 2x power minus 1. So first thing we need to check is, if this number is 1, then we can expand directly, okay? This is 1 right here, so that one is equal to 1 plus, that will be minus 1, which is the value of n, times minus 2x over 1 factorial, okay? Now we have to find minus 1 minus 2 minus 2x, that will be power of 2, and then over 2 factorial. This is power of 1, that is 1 is 1, 2. So if you guys don't know this expansion, don't worry, you will have the formula given to you on the first page of your test. It is on the list of formula to have this expansion for you. Okay, so now what can we do? We have to simplify. So that is equal to 1 minus minus becomes plus 2x plus, that is 2 cancel out, that become plus 4x squared. Okay, that is for number 1. Let's do number 2 now. So number 2, we have expansion of 2 minus x power minus 1. So now here we have a problem, because here we have 2 and we need this to become 1. So you have to factorize the 2 outside. You will have 2 outside, 1 minus x over 2 inside the bracket of minus 1. Now we have to simplify. That becomes 2 power minus 1 times 1 minus x over 2 minus 1. Now this is equal to 1 over 2 times 1 minus x over 2 power this. Now we can expand this one because this is 1. So let's do that. So we have half, and here it is 1, we write 1, plus we have to take the power, which is minus 1, and times the value of x, which is minus x over 2 power 1 over 1 factorial, plus we have n, which is this, and then n minus 1, which is this, and take the value of x, which is power 2 over 2 factorial, and that's it. So we need to stop right here because we only care about the term up till x squared. So now we just have to simplify step by step. Minus minus become plus. These two become plus, so we have to cancel out those two. Now what else? So here we have half. That is 1. And here we have plus 1 half x. And here we have plus 1 over 4 x squared. And all this we have to expand. You will have half plus 1 over 4x plus 1 over 8 x squared. That is number 2. Now for number 3, the same steps. So number 3 we have to expand 2 minus x power minus 2. So first we have to factorize the 2 outside because we want to make this become 1. Okay. Now here we have power minus 2. It will become 2 minus 2, 1 minus x over 2, and this. This is 1 over 4 times 1 minus x over 2 minus 2. Now proceed step by step. So first we write down the multiple, and then here it is 1. We write down 1 plus the value of n, which is minus 2, and the value of x here is minus x over 2 divided by 1 factorial. Now plus value of n minus 1, which is minus 3, and then times x, the value of x here is this one, power 2 over 2 factorial. Now we have to simplify. We have 1 over 4 times 1. This is cancelled out, plus x, and here we have cancel out. That become plus 3 x squared over 4. Now we have to expand to see what happens. Becomes 1 over 4 plus 1 over 4x plus 3x squared over 16. Okay. Now let's see what we need to do now. So we have the values of 1, 2, 3. We have to plug in those values back in this equation. Okay. So let me write down the equation again so we can follow step by step. So we know f of x is equal to 1 times the number 1, which is this one, plus 3 times the number 2, and then minus 2 times the number 3. Okay, so first one is this one. So 1 is, number 1 was given to you by this value. So replace, you will have 1 times 1 plus 2x plus 4x squared. Now plus 3, so we have to plus 3 times the second value. That will become 3 over 2 plus 3 over 4 x and plus 3 over 8 x squared. And then finally we have to minus 2 times this value. That will become, let me use black, you will have to use, so minus the whole thing here, that will be half plus half x, and that will be plus 3 over 8 x squared. So let's see what do we get here. Okay, so step by step, plus this 2 minus this 1. So 1 plus 3 over 2 minus 1 half. That should be 2. So you get 2. 2 plus 3 over 4 minus half. That becomes plus 2 and 1 4x. And the last one is 4 plus 3 over 8 minus 3 over 8. That should give you plus 4. Okay, so the expansion will give you these 3 terms. Now if you rewrite this down properly, you will have 2 plus 9 over 4x plus 4x squared. and that is your expansion for f of x for the 3 terms. And that will be your question number 8. Okay, so let's move on to question number 9. So without using a calculator, express the complex number. This is a fraction, and we have two complex numbers in the form of x plus iy, where x and y are real. So to simplify this, we just have to multiply top and bottom by the conjugate of the bottom. So what do I mean? Let's say I have a complex number which is x plus iy. The conjugate of that will be x minus iy. So here at the bottom is 1 minus 2i, and the conjugate will be 1 plus 2i. Okay, so we just have to multiply the top and bottom by this complex number. So let's do that. We have this over 1 minus 2i, multiply top and bottom by the conjugate. So on top you will have 2 times this will be 2 plus 4i, and this time this will be plus 6i plus 12i square. Divide by 1 square minus 2i square. So just to explain this real quick, so as you can see, this looks like a minus b, and this is a plus b. So as you guys know, this is equal to a square minus b square, so same thing, this happened, right? Now to simplify, so we have to know I square is equal to minus 1. So 2 minus 12 will be minus 10 plus 10i over, this is 1 minus 4i square, minus 10 plus 10i over 1, this is minus 1, that will become plus 4. So finally that will become minus 10 plus 10i over 5. That will become minus 2 plus 2i. And that is your answer in terms of this form where x and y are real numbers. That is part 1. Now for part 2, we have to, hence, without using a calculator, express this, which is now we know it is minus 2 plus 2i, in the form of this, where this and this, it is between this, giving the exact values of this and this. Okay, so step by step. So what are we looking for? So let's call this one this. Let z equal to minus 2 plus 2i. So to understand what we are looking for, we can make a small diagram. Okay, let's say this is the imaginary axis, and this is the real axis. Okay, so this is the real, and this is the imaginary. So let's label this as 1, 2 and 1, 2. That will be about here though. So this is minus 2 and 2i. So this is minus 2 and 2i will be this point. This is your complex number z. Right. Now by joining these two, and you can see this height will be 2 and this base will be 2, and here we have a right angle triangle. So the value of r is actually this length. Okay, so r will be the length, which can be found by using the Pythagoras theorem, which is 2 square plus 2 square. That will be root of 8. That is equal to 2 root of 2. So just to explain, how is that possible? Root of 8 is also equal to 4 times 2. Now root of 4 is 2, and then root of 2. So that's why you get this answer for your value of r. That is the exact value. Now to find the value of theta, theta will be the argument, which is, we have to find this angle. But first we can try to find this angle, right? How would you find this angle? So if you observe, we can use SOHCAHTOA. So this angle, we have to use tan is equal to, this is the opposite side over the adjacent side, 2 over 2. That will be 1. Now we have to know by now, this is tan inverse of 1 is equal to pi by 4. But you can always check, so tan inverse of 1 is 45 degrees, which is pi by 4. So pi is 180 divided by 4, which is 45 degrees. Now we have to find this one, So theta will be, so pi minus this will become 3 pi by 4. Okay, as you can see, this is a straight line. This big angle is pi, which is 180, minus 45 will give you this value, which is 3 pi by 4. So finally, let's write this down. R is given to you by 2 root 2 times cos of theta, which is 3 pi over 4, plus I sine of 3 pi over 4. And this is your answer for question part 2. Okay, so now let's move on to part B of this question. So on a sketch of an Argand diagram, shade the region whose points represent the complex number z satisfying both the inequalities. So the first one is this, and we have this. So whenever you write this one down, when you have minus here, always make a bracket. You can see the real part is 0 plus 3i. So that is your point, your center of rotation, and that is your radius. Radius will be 1. So basically, the distance from this point of the complex number z will be always equal to 1 or less than 1. Basically, it will be a circle or a disk. This is your center, and it will have a radius of 1. Okay, that is the first locus we have to draw. Then this one, the real part of z have always to be less than 0, which will be on your left hand side. Okay, so now let's draw the Argand diagram. So let's do this on this side. So, okay, and here we have the base. So let me try to make this pretty big so you can have a look to see what's happening. This is 1, 2. Okay, so you have to label your axis pretty well, and that is 1, 2. Okay, this is your imaginary axis, and this is your real axis. Okay, so I'll take 1 here and 2. That will be minus 1 and minus 2. Same thing, I'll take I, 2i, and 3i. That will be 4i. Okay, so for the first one, we have to draw a circle from the point 0, 3i. So 0, 3i will be this point, and the radius has to be 1. So go to your point 1 here, make a mark here, and same thing, measure 1 on this side and make a mark on this side, and then here we have to make a mark here and here. So we have to try your best to make a circle for this one, right? So here we go. Okay, you can always use a compass if you want to, but you can also just use your hand. It is a free drawing, so it is a sketch, so you don't need to be exactly a circle. It is only a sketch. But now, of course, do not draw a square. It will not be valid, okay? Now, that will be the first one, but we have to shade the inside. But since we have another one, it tells you that it has to be on only this side. So your answer will be this side. Only this part of the circle will be the region that you need to shade. That is, the point Z can be in any points in this part of your circle. Okay, now that is part 1. Now part 2 here is find the greatest value of argument of Z for the points in this region. So we have to test and see. Okay, so let's say my point Z will be somewhere around here. My argument will be not the greatest. Now if I can move the furthest away, my argument will be increasing. So if I move, that is the furthest away I can move. So from this point to this point, that point will be my largest value where Z can be. So my argument can be the greatest. Now, you have to observe this line is a tangent to the circle. If you join this point to your center, this has to be 90. Okay, so basically now for the argument we are trying to find this angle, but if you observe this is 90, So we just have to find this one. Let's call this one alpha, and then we can take alpha plus 90 to find the argument of that complex number z. So here we have a right angle triangle. The radius is 1, we know that, and the height is 3, right? So we can use SOHCAHTOA to find the value of alpha. So here it is your opposite side, and here we have your hypotenuse. You have to use sine. So sine of alpha is equal to 1 over 3. So alpha will be sine inverse of 1 over 3. That will be 0.3398. Now to find this argument, which is this big angle, we have to plus alpha plus this one. Argument, let's call this one theta, is answer plus the value of pi by 2. That will be 1.91. So you have to know that pi is 180 and pi by 2 is 90 degrees. So this is only pi by 2 plus alpha. So correct to 2 decimal place, the largest argument of largest argument will be 1.91 radians. Okay, and that will be your question number 9. Now let's move on to question number 10. The line L has equation r equal to this plus lambda times this. This is the direction of your line L. Now the plane P has equation this. Okay, now part 1, the line L intersects the plane P at the point A. Find the position vector of A. So we know that the line L intersects with the plane P. So step by step, let's rewrite down the line L. So L can be written as R equal to 5 minus 3 minus 1 plus lambda times 1 minus 2, 1. And this is equal to what? We can also expand. You will have 5 plus lambda minus 3 minus 2 lambda minus 1 plus lambda. That will be your value for R. Okay. Now for the plane, if you observe here we have R, we can write this down again. Plane P, R minus, you can put bracket if you want to, I minus, so minus become plus 2j. And we have to apply dot product with 3i plus j plus k equal to 0. So let's expand this. So we have R times this, and then minus I plus 2j dot this one. Okay, so let's try to replace the values and expand to see what happens. So here we have R and here we have R. We can expand, we can replace basically because we know they meet with each other. So we can solve this by simultaneous equation. So R is this, which is 5 plus lambda minus 3 minus 2 lambda minus 1 plus lambda times, this can be written as 3, 1, 1 minus 1, 2, 0 times 3, 1, 1 equal to 0. So now we have to simplify. This one will become 3, 5 plus lambda plus minus 3 minus 2 lambda plus minus 1 plus lambda. This is what? So 1 times 3 is 3 plus 2 is 5. So here is half minus 5. Now we have to simplify. That will be 15 plus 3 lambda minus 3 minus 2 lambda minus 1 plus lambda minus 5 equal to 0. So here we have to find the value of lambda. Simplify. 3 minus 2 plus 1, that will be 2 lambda equal to 15 minus 3 minus 1 minus 5. That will be 6. We send 6 over here, becomes minus 6. Lambda will be minus 3. So now to find the position vector of A, so OA, we have to replace the value of lambda in the main equation. So you will have 5 plus lambda minus 3 minus 2 times lambda minus 1 plus lambda. So 5 times 3 is 2. Minus 3 plus 6 will be 3. Minus 1 minus 3 minus 4. So that will be the position vector of A, or you can write this down as 2i plus 3j minus 4k. That is OA. That is for part 1. Now let's move on to part 2. So we have to calculate the acute angle between the line L and the plane P. So when you have this kind of questions, it's always best to make a drawing to know what's happening, okay? So first let's draw your plane. This is your plane P. So with the plane, as you guys know by now, we have a normal. What is your normal? So going back to the main equation given to you here, the normal is this one, okay? So let's write this down. The normal of plane P is given to you by, it shows to be 3, 1, 1. Now something here we know is that the line L passes through the plane. So let's say it passes somewhere around here. Let's say it's here, for example. Let's make it easy for you guys. Let's say it passes through here, for example, right? Okay, and this is the horizontal line, okay? So here, this is your line L. This is the direction of L. So the direction of L has been given to you as well in the first part. It is this one, 1 minus 2 and 1, okay? So that is 1 minus 2 and 1. So first we can find the angle between the normal and the line. But to find the angle between the normal, between the line and the plane, we have to take, this is 90. This is 90 minus this one to get this one. So first, let's find the angle between the normal and the line. That will be using dot product, direction of L, cos of theta. So this one is 3, 1, 1 times 1 minus 2, 1 is equal to magnitude of n will be, it will be what? It will be this. We have 9 plus 1 plus 1, that will be 11. Now it will be 1 plus 4 plus 1, that will be 6 of cos theta. This will be 3 minus 2 plus 1, that will be 2. And that will be root of 66 cos theta. So theta will be cos inverse of 2 divided by root of 66. That will be 75.7 degrees. But this is not what we are trying to look for. We are trying to find the angle between the line and the plane. It has to be 90 minus this angle. That will be 14.3. Yep, degrees. And that is your answer for the angle between the plane and the line. Now let's say in an exam you forget what to do, right? So the thing you have to do is, whenever you see a line and a plane, you first just find the angle between the line and plane. That's the first step. Let's find the angle between the line and the plane. So once you find this angle, second step is to take 90 minus the angle to find the angle between the plane and the line. So just to recap, whenever you have to find the acute angle between the line and the plane, the first step, just find the angle between the line and the normal. So normal. So you have a normal here. It is always given to you. You can first find this angle. And then when you find this angle, just take 90 minus this angle to get this value. So that will be your answer for the angle between the line and the plane. So that is if you forget what to do. Okay, that will be question part 2. Now let's move on to part 3 of the question. So find the equation of the line in which lies P and intersects L at right angles. Okay, so step by step, let's call this line the line of S. S, we don't know the direction. So what is the direction? So let the direction of S be A, B, C. Okay, so let it be that, right? Now the first thing we can see is that is this direction of S. So we know that the line S intersect the line L at the right angle. So we know that their direction has to give you, the dot product has to give you. So what is the direction of line L? This is given to you as 1 minus 2 and 1 has to give you 0. So that is the first equation that we can form. That will be A, and that will be minus 2B plus C equal to 0. That is equation number 1. Now other one is, if you draw a plane, for example, plane is defined by its normal, right? Now if the line S lies on the plane, for example, so the direction of S has to be at right angle with N as well. So the other equation we can form will be ds dot product of N has also to be 0. Now we just have to replace the values. That is just A, B, C times the normal has been given to you as well. It is 3, 1, 1. That is supposed to be 0. Now we have to multiply, do the cross dot product. That will be 3A plus B plus C will be 0. That will be your equation number 2. So now we can simplify. Just take number 1 minus number 2. You will have A minus 3A, that will be minus 2A, and minus 2B minus B will be minus 3B, and C minus C will be 0 equal to 0. So minus 2A will be equal to 3B. Now if you replace A is equal to minus 3 over 2B. Okay, that is my, let's call it my equation big one. Equation big one. Okay. Now replace the value of A back in the equation. Let's say I put this back in the first one. You will have what? So minus 3 over 2 B minus 2B plus C equal to 0. So C will be 2B plus 3 over 2B. That will be what? 2 plus 3 over 2. That will be 3.5, which is 7 over 2B. So now we just have to find the ratios of A, B, and C. So A, B, and C. A is minus 3 over 2. B is 1. C is 7 over 2. Now to eliminate those two, we have to multiply by 2 everywhere. So here you will have minus 3. You will have 2 and then 7. So as you can see, the ratio will be A can be minus 3, B can be 2, and C can be 7. Now if you want to, you can also write 3 minus 2 minus 2 minus 7. It's the same thing. Okay, this is just the direction of your line S. Now to find the equation of the line, we have to find a passing point and the direction, which we know already, which is minus 3, 2, 7. So since the line S lie on the plane, we can choose any point on the plane. And as we have done in part 1, we know that this point is on the plane, so we can just choose this point, which is 2, 3, minus 4. And this will be your line S that passes on the plane and intersects the line L at right angles. So that was the last question of this paper. I hope that was somewhat helpful. As always, I do appreciate you guys watching, and don't forget to leave a like if you find this helpful. And of course, since exams are coming up in the next few days, I will be uploading more videos on paper 3s. And don't forget to subscribe and turn on the bell notification for future videos. And thank you for watching. I will see you soon.